action.
Hello, I'm Holden Larson. This is Mr. Ward's class, March 21st, 2018, period 5, pre-calculus.
Period 4.
Period 4, pre-calculus.
Hey, take 2. All right, go. No, stop, go. Sit. All right, okay, all right. Section 6.2, here we go.
Lars, how did you get the period?
All right, law of sine. Law of cosine, sorry.
Law of sin, cosine.
Cosine. I wrote sine, I meant cosine.
Did we do sin yesterday?
We did sine yesterday. We did some example problems, so I know like some people were gone yesterday. We just did some practice problems. We did a little group activity where we tried a couple problems out. You guys walked up to the board. Not all groups presented. That's fine. We're going to get another chance to present at a later time this week. And we're going to go through all the problems. So some of the groups who didn't get to go will get to at some point this week.
Can we volunteer as tribute?
No. Nice. All right. Today, I want to show us what the actual formula for the law of cosine is today. So we're going to show how it was derived, what it comes from. I'm going to show you that today. It was something I hinted at yesterday, and it was based on solving for missing parts on oblique triangles. Solving for missing parts. The big thing is oblique triangles. Triangles that are not 90 degrees. They're random. But these, we can actually solve for the missing pieces. All right. Questions, comments about what we're going to be doing?
No.
All right. The goal today. We don't have a lot of time. I want to show us how the formula is created. I'm going to give you that one problem that I had something on the board. It was something like this yesterday, where you had a triangle. Let's go with A, B, and C. And again, this is no particular triangle. It's not. It doesn't have to be obtuse. It doesn't have to be right.
You always draw the same picture.
Yeah, it's just a generic picture I always draw. Let's say this is 20 degrees. Let's say this is 10. Let's say this is 14. All right. Okay, these are my random numbers. So if you're looking at the picture, this is one that we talked about yesterday that I said we couldn't solve yet.
But now we have an angle.
Today we will be able to.
Per se.
So when you look at this, here's the little acronym that goes with this triangle. SAS, side, angle, side. If this is your setup, we can use a new formula today, which is the law of cosine, to actually find the answer. I want to show you what the formula comes from, and then write down the actual formula. So this first part's going to be it's going to be like the tie-in, like where does it originally come from, and then I'm going to show you how to use it, because the most important part here today is actually knowing that if I gave you the formula, could you plug the numbers in like right now? You only need these 3 numbers, which is kind of the nice thing about the formula itself. You need the two walls and the angle that's in between them. That's how it usually works. What the formula will give us, it will give you the opposite wall to it. That's what the formula gives you. So if you have the 2 walls and angle in between, it will go across the picture and find the 3rd wall. That's what it's used for.
Is this the inappropriate acronym?
No. Now, let's go through how they actually came up with it, so hopefully it'll make sense to you. And so this first part doesn't require that you know any formula. I'm going to show you very common sense ways on how they came up with it. Okay, so first thing, if you want to attempt this problem, there is a way to do it. Here's how you could do it. You could draw a line, which is an altitude line, straight down. Now what an altitude is, it's a 90-degree wall. It separates the large triangle into 2 smaller ones. In fact, the 2 smaller triangles are actually right triangles
So we
now.
use the Pythagorean Theorem.
Okay, you can use Pythagorean Theorem, which is a part we'll look at later. And/or, instead, we can actually do SOHCAHTOA and do all the basic trig functions, because it is a right triangle. So, if I wanted to find this piece right here, let's call it x. And x is this side from here to here. That's all x is. I can actually find x using a Pythagorean theorem, because I have an angle, a wall that's next to it, and then the hypotenuse. This is actually the hypotenuse of this right triangle. So to find x, I would use cosine. Cosine of 20 is x over its hypotenuse. And the hypotenuse is 10. Now, to actually set this up, you have to multiply the 10 across, because the 10 is on the bottom, so 10 times the cosine of 20 that is how you find x. Now, whatever that number is, I don't even care what it is.
I want
If it's a decimal, it's fine. I don't even want it right now.
9.8.
Hey, I don't want it. So here's the number for x. Now, to find the number that's on the other side of x, this mystery number over here, all I have to do is take 14
subtract
and
that
subtract this.
number, which, if you were wondering,
No, I don't care about it. So,
It's 9.8.
all right. Does everyone understand like how I got those two parts?
No.
Okay.
Well, I thought you said it. It's everyone. Just
Yeah, Holden, Larson, and J. Spriggans.
Boom. Okay. All right. Perfect. All right. Hey, let's keep going. Hopefully everyone's writing down the steps I got. And again, this x was this number, which I think somebody was going to say was about 6-ish. Then this number
it's
over
more
here
like
is 8.
9.3.
Over here is 9-ish. Okay. But those two numbers are important. We're going to look at those later. Now, to find x, or not x, but y here.
Why?
Now, to find y, I'm going to use the same 20. I'm going to use the same 20, but I'm going to find y instead. So that sine of the 20 degrees is the opposite wall, which is y over 10. So it's the opposite over hypotenuse.
So
and
the
to solve for
sine-
y, I would multiply this across, so 10 times the sine of 20. Now, there's a purpose why I'm doing this.
I got
I'm going to show you here in a second. But this number right here
1, 4, 3, 3.
is 10 times the sine of 20 degrees.
Which is
Okay, no.
3.42.
I don't want to know. Okay, does everyone have the parts labeled?
Yes.
Okay, now why I did this is because now I can actually find this piece over here, which I'm going to call little a. I'm going to find little a. That was the purpose of what the law of cosine does. It finds the wall all the way across the picture. And there's a generic formula for how you find it. I'm showing you how they came up with it. And this, what you're actually seeing, all these little pieces I'm finding, is actually the lead up to the formula. It actually explains why the formula works and what the formula is. Because what the actual formula does is it does all of this stuff that I'm doing for you automatically in the background, and it calculates what A is. It makes the triangle into two right ones, and then it calculates this one, which one of you in here actually said the process of it, which is the Pythagorean Theorem. Okay? That's this triangle right here. I actually have two of the walls, and I can find the third wall because it is a right triangle. So I can do the Pythagorean Theorem on this piece.
Why don't you write the
So-
decimals? Why can't
Okay,
I write
because
out
I want to show you what the formula is so you can see the parts.
When we're doing it, would we write the decimals?
No. You will, but I'm showing you where the formula comes from.
But,
Okay.
so when
So
it's
like when
large
we're
form,
actually doing a problem,
we will
Yeah,
write
there won't be a lot of
3.42,
decimals though. A lot of the problems will have whole numbers in them.
but we'll write the number.
The number.
Yes, you'll write the actual digits. But the thing is, the reason I'm not having you write the decimals, because you won't have to do that stuff.
Okay, I understand that, but when we do the problem, this isn't what we write.
Yeah, this is showing you where the formula comes from.
You're just kind of confusing us, Paul.
Okay, no. Okay, all right. So to do Pythagorean Theorem, here it is. It's a squared plus, I shouldn't use the a here, but it's this wall squared, the leg squared, plus leg squared, because these are the legs, it's just a 90, equals the hypotenuse squared. I shouldn't use the letter a. So here's how it works. 10 times the sine of 20 squared, that's one of the legs, that's this side, squared, added to the other leg, which is 14 minus 10 times the cosine of 20 squared, and that equals the wall I'm trying to find squared, because that's the hypotenuse wall. Now, what I'm going to try to show you is the actual generic formula using these numbers. And then once I have the actual final formula, what it is, I'm going to come back, erase all these parts, and show you how you can just immediately get to the answer using the formula. But this is showing you the generic way how they actually developed it. It's a set formula that works every time. Okay, so if we square these, we square this item, this is one item, when you square it, you actually distribute the square because it's one item on the inside. So this is 10 squared times sine squared of 20. Again, I'm not squaring anything, I'm not writing any numbers or decimals or anything like that yet. Over here, if I square this, there is two parentheses, which is 14 minus the 10 cosine 20, 14 minus 10 cosine 20, and I have to FOIL it first, outer, inner, last. So 14 times 14 is 14 squared. 14 times negative 10 is negative 14 times 10 cosine 20. Negative 10 times 14 is negative 14 times 10 cosine 20. And the last part is negative 10 times negative 10, which is positive 10 squared cosine squared 20. And so that's doing the last items multiplied together. That's the 10 squared cosine squared. And those are positive in the end. And then this is all equal to, I'm just going to put it over here, a squared because I ran out of space. So that's everything. Now I know it looks like a massive stuff, and it looks like, God, there's things everywhere, and there's cosines and squares. It will simplify here in a minute, and it will be the generic formula, which I'll show you how to work it.
But wouldn't it be pretty simple, like, when we do it ourselves, and we don't have all of that stuff, and just other numbers, like...
So the problem is the formula itself is lengthy. And so you will have a bunch of terms you're going to have to plug in certain
But
spots.
this will simplify it.
Yeah, to get to the point, yes, I will write the decimals down.
It will simplify it.
Okay, I'm trying to show you where the formula comes from. Alright, next. I'm going to move this item up front. Okay, here's the reason why I'm moving it. They both have 10 squares, and they both have a trig function squared on them. So, if I rearrange this, 10 squared, sine squared, hey, stop talking, it's annoying. Plus, hey, I don't want to hear it. 10 squared plus cosine squared 20 plus 14 squared minus, and there's actually two of these, I'm just going to combine them. There's two of the 14, 10 cosine 20s. Okay, let me get rid of this arrow. And again, all I did was move that one item way out front.
That's so weird.
And the reason why I moved it, why I moved that back item all the way to the front, is because these items, there's something in common here. That they both have a 10 squared on them, and when I add them, I can't add them because they have different sine functions, or different trig functions I should say, but I can factor it out. So if I factor out the 10, here's what I'm left with. Cosine squared 20. So if I factor out the 10, this item is actually on your property sheet. It's a Pythagorean identity that sine squared plus cosine squared of any angle is always the number 1. So this is a 1. And if I get rid of it, here's what I have. I have 10 squared. And this is actually getting down to the generic formula now. Question?
What does 10 squared cosine squared OO mean?
It's supposed to be 20.
Oh, that's 20. That's a 20 thing. Yeah, thanks. That was a 20. All right. Anyway, so we have the 20, we have the 14. Because again, all I did, this item right here, these combine to make 1, so that's just a 10 squared. 14 squared minus 2 times 14 times 10 times cosine of 20. This part right here is the generic formula for the law of cosine.
That's big.
It's big. It's way bigger than the law of sine. It is a very large formula, but once you see how to use it,
But 10s and 14s, that's the generic.
No!
yeah, well,
That is
yeah, it's the formula with the 10s and 14s from the picture plugged in.
Okay.
So let me show you how it works.
Absolutely.
Okay, stop.
Oh my gosh.
All right. So if you have that part in the box, I'm going to show you what the formula is, and then we're going to come back to this picture here. All right, here we go. We get rid of all the markings on the picture. All right. So here's what the law of cosine actually says. To find the wall that is across from your angle, to find that wall, if it's a side angle side problem, it's the wall squared what you're trying to find, okay, which in our case is A. And I'm going to use the letters from this picture. So this is lowercase b, this is lowercase c, this is angle A. So I'm using the lowercase letters. So here's the generic formula. You square the two walls that are around your angle, b squared and c squared. Okay, so I'm using the walls that are right next to the angle that I'm using. Then you're going to subtract 2 times both walls that are around the angle, and you have to take that times the cosine of the angle that's in between those two walls. So what it is a squared equals b squared plus c squared minus 2 times b times c times cosine of the angle in between them. And that's actually what you're seeing there in that generic form. that they're using the two walls that are around my angle, so 10 squared, 14 squared, minus 2 times 14 times 10, times the angle that's in between them as a cosine. And that's actually what you're seeing here. Now, I know most people look and go, Ward, I can't remember all of that. I'm not even joking, I don't even think about the stupid A's, B's, and C's. I don't think about the letters from the picture. When I do this problem, this is like the generic thing that every textbook gives you. When I see this problem, and I know I need to find the wall across from it, I know that it's going to be the wall squared. You're going to use the two walls, square each of them, so it looks like the Pythagorean Theorem. Right? It looks like the Pythagorean Theorem, a squared equal, or b squared,
Minus.
you know. And then you just have to remember the back part that you're subtracting. That's really the only thing you have to do. So the two walls you're using, it looks like Pythagorean Theorem to make the third wall. But then you just have to remember this little extra part where you're using
It's on our sheet.
the two walls. Yes, and it's on your property sheet.
Of course
So,
it is. When will I remember?
so it's just one of those things that, for how I remember it, this is how I do it. I really only have to memorize the part they're subtracting on a Pythagorean Theorem, even though it's not a right triangle. Which is the 2 times the two walls and the cosine in between. So it looks like Pythagorean Theorem with an extra piece, because it's not technically a right triangle. Okay, but that's it for today. That's all I want to cover. I want to cover the formula itself. Tomorrow we're going to do a bunch of examples. Later this week I'll have groups present that haven't presented yet. We'll try some more problems with this stuff. And
volunteer.
and I want to make sure that we are going to get to some story problems, like how to use this stuff and practical application of it.
Don't mind.
So some of the stuff we're going to be doing later this week is going to be, I think, kind of fun. We're going to watch some videos and stuff and apply some of this stuff.
Pyramids?
So nope, it's going to be on some actual like basic problems, some real life.
Pyramids are
Pyramids are real.
Nah, I'm not talking like some weird
Some
ancient
real
stuff. I'm talking about like more modern day.
Okay, how do you think they built them so perfect though?
Good engineer, like really skilled.
They use math like this.
Yes, but they didn't have any machine.
Doesn't need to if you have human power.